Hey guys, it's Miss Martinez, and before we start our video, I want to make sure that you have already set up your notebook. If you have not, please watch that video first before you continue on this one. So we're going to start at the very first page, and we're going to write the date, which today is 8/24. The topic is going to be the real number system, and the page number is going to be page number 5, right? So on page number 5 at the very top, I want you guys to write learning target, and let's see what the learning target is. So the learning target is to review rational numbers and extend understanding to irrational numbers. Our title again is the real number system. And our essential question is basically the question that I want you guys to be able to answer at the end of our notes. Okay, and that is going to be, how are counting numbers, whole numbers, and integers and rational numbers related? Right. So let's go ahead and get started with the very first section. It says, what are rational numbers? So let's see what those are. That's any number, any whole number, fraction, mixed number, or decimal, including their negative counterparts. Okay. What is irrational number? Let's see what that is. It's a number that in decimal form does not repeat or end. So it goes on forever. It goes on. It's a very long number. Okay. In the next section, we're going to make a tree map, and at the very top of our tree map, it's going to be the real numbers. So we're going to talk about the real number system. We have two categories in real number system. The first category is irrational numbers, and that's a new word for you guys. The most popular irrational number that people know is pi. Another example of an irrational number is this: 0.01001203 ... Those ... dots mean that it goes on forever. And remember, it says right here, irrational numbers are numbers that don't repeat and they don't end. Okay. The other type of real numbers is a rational number. Okay. Those, like we said, those include whole numbers, fractions, mixed numbers, decimals, including their negative counterparts. So there I have a few examples. Okay. A subset of rational numbers is going to be an integer. So they're basically rational numbers, but without the fractions. So they include positive numbers, the number 0, and negative numbers. And here are some examples. Okay. A subset of integers is going to be a whole number. Okay. And those include just positive numbers and 0. So basically 0, 1, 2, 3, 4, 5, all the way to infinity. Okay. And then another subset of whole numbers is going to be a counting number, or sometimes they're called natural numbers. And those just include positive numbers. Okay, so 0 is not included, negatives don't include it, and fractions are not included. Right? Okay, so we're going to use this tree map to guide us to see the most specific classification of 5 numbers. And the very first number that we're going to specifically classify, is the number 5. Okay, so I'm going to get let's see how big that is. Okay, I'm going to make it a little bit smaller. Okay, awesome. So let's look at 5 right here. So for 5, I know it stops, so I know it's not irrational, because irrational means they never stop, but 5 is just 5, right? So I know it's rational. Let's see if we can go down to integers. So 5 is a positive number, and then here it says integers can be positive numbers. So it is a positive number as well. Okay, let's see if we can keep going further down. Is it a whole number? Yep, it's still a positive number, so yeah, it could be a whole number. Let's see if it can be a counting / natural number. Okay, and yes, it's even in the example right there, right? So 5 can be all of the things to the left, but the most specific it can be is going to be a counting / natural number. Okay, let's look at the number -7. Okay, -7, it stops, so I know it's not irrational, so let's cross that out. So let's look at rational. I know it's rational because it's not irrational. Let's go down to integers. Can it be an integer? Yes, because right here it says negative. So yeah, negative numbers are included in the integer section. Let's go down to whole numbers. You know, right here it only says positive and zeros. It doesn't say anything about negative, so I know it can't be a whole number. So the most specific -7 can be is going to be an integer. So using the tree map, I want you guys to identify what is the most specific classification of 1/2. Okay, and I'll give you a few minutes. All right, so hopefully you guys got a rational. It's a rational because 0.5 is a half, right? 0.5 ends. It doesn't go on forever. So I know it's rational, but then I can't go down to integers because it says no fractions. So the most specific it can be is a rational number. Right. The next one, try to give me the most specific classification of 0. Right, so hopefully you guys got a whole number. A whole number. It has to be a whole number. That's the most specific classification it can ever be. It can't go down to counting numbers or natural numbers because that doesn't include 0. Okay. What's the most specific classification for 2.332134 ... Remember those dots? They mean that it goes on forever and ever, right? So which one would it be? Right, so hopefully you guys got irrational number. Okay, this is a tricky one because, you know, right here I have a decimal that goes on forever, but this one repeats. Remember, on irrational numbers they can't repeat and they have to go on forever. But like the question here, nothing repeats in there, so it's going to be an irrational number. All right, so those are our notes, and before we end our notes, I want you to do 2 things. So first thing is I want you guys to write your summary, and in the summary you're going to answer your essential question, which was this: how are counting numbers, whole numbers, integers, and rational numbers related? So in your own words, you're going to answer that in your summary box. If you don't have space, make space just like I did. All right, so that's the first thing I want you guys to do. The next thing I want you guys to do is either get a highlighter or a pencil, a color pencil if you have one, and I'm going to highlight 2 of the most important words in the set of notes. Okay, okay, so I'm going to zoom in and I'm going to highlight rational and irrational. I need to know, and I need you to know, the difference between rational and irrational. Okay, and that'll help us a lot in tomorrow's homework and then later on this year. Okay, all right, so this was today's notes. If you guys have any questions, please let me know. You can come to the meeting that's 1 to 2, or you can always email me. All right, so I hope you guys have a good day and be safe.